Hello there. Welcome again to the aekiti Embassy YouTube channel. Unlike other tutorial videos, I will show you how to follow the provided SmartShop Sophia example amidst other awesome example on the GitHub repo. To start with, I would explain the whole process of this example, explain its smart contract, unit test script, deployment script, and finally execute command to test and deploy the contract of this example. Without further ado, let's get started by heading to the æternity GitHub repo that houses this example. To do that, I'm going to go to github.com/æternity. Okay, to locate the repo that houses this example, I'm going to search for app Sophia Examples. Yes, we have it here. So we're going to go here. And as you can see in this repo, it has libraries, Sophia libraries included, from the datetime library to the list library to the ownable, fungible tokens, non-fungible tokens, multi-signature, base converter. And then we have the examples: SmartShop, Crypto Monster, Real Estate, Data Provider, Spend to Many, and Tic-Tac-Toe. So for this tutorial, we're going to head to the SmartShop example. Okay, now that we have seen other examples and Sophia libraries, let's get down to the main business. The SmartShop Sophia example is a powerful type of example as it demonstrates how one can build an e-commerce decentralized app on æternity blockchain. This example makes use of 3 different contracts. Yes, you heard it right. 3 different contracts to achieve a goal of decentralized buying and selling. The contracts are named the seller contract, the transport contract, and the buyer contract. The seller contract helps send items to the transport courier, track the item status, and most importantly, get the item price in AE token once it has been delivered to the buyer. The transport contract helps the buyer to track the movement of the item and also the status of the item right from the seller through the transport courier. And lastly, the buyer contract helps the buyer to deposit the item price, check the item status, and finally pay the seller upon the successful delivery of the item. Okay, the newbie would be wondering, how is a single system using 3 contracts? Well, that is the beautiful thing about this example, as the contracts are dependent on each other. Okay, enough chit chat. Let's head to VS Code so I can explain the example code. So I'm going to open my VS Code right on this repo. To explain this example, I'll make use of a Windows operating system with a perfectly working AE project. If you don't have AE project installed, kindly check out our video installing AE project on Windows or Ubuntu operating system. For quick access and delivery, the links to these tutorials will be on the screen. Okay, let me start by explaining the contract for this example. So I'm going to go to the example directory and we have the SmartShop example. And inside the SmartShop directory, we have the contract that houses the 3 contracts. I'm going to start explaining right from the seller contract. The seller contract stores the seller address, the buyer address, the item status, and the item price in its state. This state is returned in the init function after passing the buyer address and the price as an argument. Then the state variables receive their default values, where the seller address is the core.scholar, which is the address deploying the contract. The buyer address is the early defined buyer address. The status is marked as undefined. And lastly, the price is the early defined price. Then It has an in-house function that checks if the buyer has sent the early defined item to the contract. Then it has a send item stateful entry point that returns the item status as a string after it has checked if the item price has been paid, and then sends the item to the transport courier by changing the item status. Then it has the receive item stateful entry point that is only accessible by the buyer. It changes the item status to deliver, then sends the item price to the seller address. These explained two functions are the primary functions of the seller contract, as the remaining functions help the smart contract and the whole system process. The caller balance returns the A value of the call, the call.caller, and then the sell contract balance returns the contract balance, and finally the check item status returns the status of the item. Now to the transport contract. This contract houses location, timestamp, and status of the courier movement in its state. The init function entry point takes the parameter of the default city of the courier service and then returns the contract default value of the state after saving the location as the requested city. The timestamp is the current chain, the timestamp, and lastly, the status is marked as on way at the initial stage. Then it has the change location stateful entry point that takes the current city as an argument to update the item, location, and timestamp. And the most important primary function is the delivered item stateful entry point that saves the current location of the item, the change timestamp, and finally the status to delivered. Then the check courier status returns the movement status, while the check courier location returns the current location of the item movement. And finally, the buyer contract that interacts with the seller contract and the transport contract. The first thing that was done in order to interact with this contract is to write out the functions needed from the contract after declaring the contract name. So the seller contract interface was declared and then the needed functions were added. This includes the received item with the return type, the seller contract balance with the return type, and lastly, the check item status with the return type. Then the transport contract interface was declared and the needed functions were added, starting from the check courier status that is returning a string, and then the check courier location that's also returning a string. This is where it gets interesting. As the early declared contracts were made the state record for the buyer contract. As you can see, the buyer contract has two properties in its state that were made a type of the seller interface and the transport interface. Then the init function has two parameters that accept the seller contract address and the transport contract address. This could accept the contract address because the type of the parameter were the early declared contract names. With this, the state property now has the contract address respectively for the seller contract and the transport contract. The main purpose of this contract is to communicate with the first two contracts in order to know the all order status, number one, after depositing the item price to the seller contract, number two. So this buyer contract, what it's doing is depositing the price item to the seller contract, and then it is tracking the order using these two contracts. To deposit item price to the seller contract, it makes use of this deposit to seller contract that takes the seller contract address using the state, and then the item of the price as call.value. Then we have the received item entry point that performs the received item function, which is also known as entry point of the seller contract. Then the seller contract balance entry point checks the seller contract balance, and then lastly, the check item status returns the item status from the seller contract. Also, the check courier status entry point returns the item movement status, and the check courier location entry point returns the item location from the transport contract as well. All right, we have covered the contract aspect. So let's head to the unit testing script, deployment script, and finally execute command that tests and deploy our contract. The unit test script can be found on this test directory with the name contracttest.js. The unit test script interacts with our contract by checking if our contract functions does what was intended to do. This is achieved by deploying the contract with the deployer method of the AE project lib package. So the first thing we did was to define our contract, which was the parts of the contract. We have the buyer contract part, we have the seller contract part, and the transport contract part. These are also, if you check this location, it's pointing directly to this contract here. So the first thing we did that houses the whole test script is to describe the contract, the test name in our case, which is SmartShop contract. Then we define these two variables, deployer and the buyer deployer. And then these variables, the owner key, wallet, and the buyer key pair. This variable, owner key pair, is the first wallet we get after running our aproject.env command, while this is the second wallet we get. Then, before starting any script, we said let our deployer equals to the new deployer, which we are running locally, and we are making use of this first owner key pair for the deployer, and then the buyer deployer, we're making use of the buyer key pair for that. Then we have this first test script that deploys the contract and gives an error if the contract could not be deployed. And that is done with this simple code that we deploy the contract with this contract part, and then we passed in the init parameter needed for the contract. As we saw in the seller contract, it needs the buyer public key and also the item price, which this was what it did, and this address seller got the contract address after it has been deployed. So this gives a successful message if it was deployed or not, and the same procedure was done for these remaining contracts after passing in the required init parameters. Then this second section for the test script is where we interact with our contract. So the first thing we did was to deploy the contract again. After deploying the contract, we ran this first test that should deposit item price to the seller contract from the buyer contract. If you see in this deployment, the first thing that was done was to get the contract itself, which is this seller contract equals to this deploy. After then this address seller gets the seller contract address. So we have all this that deploys the contract, and when we are trying to deposit the item price to the seller contract from the buyer contract, all we did was to call this buyer contract, and then we call the function and pass in the required parameter. In the case of this deposit to seller, this is how you pass in a call.value in preferences brackets, the curly bracket, and we have the amount, and which is 100. That's the amount we want to use to test, where the seller had already said, okay, the price of this item is 100 ethos. And then we have this other test that checks the seller balance from the seller contract. It follows the same procedure where it's called this seller contract and then the function, and it does that. And since we deposited 100 into the contract, our seller contract balance should definitely be 100. So if it is not equal to 100, it is to give an error. And then we have this test that is sending the item from the seller contract, and it's checking if the function now, if it was executed successfully. If it is okay, then don't give us an error. If not, tell us something is wrong. And then we have this test script that said to check the item status from the seller contract. So the same procedure, and then we call the function. And then at this stage, we are checking if the seller contract item status is now equals to sent to the transport courier as it was on our smart contract. Then we have this one that says should check the courier location from the transport contract. At the beginning, it should be Abuja. Okay, sorry, this is changing the location, which is Abuja, and if it's successful, tell us it's successful. And this is also checking the courier status as with the transport contract now. And since at the initial state, we said it should be on the way, and what we are doing with this script is to check if that contract is on the way. And then we have this that should check the courier location from the transport contract. And as you can see here, we changed the location to Abuja, and definitely for a successful test, this must return Abuja. Finally, should deliver the item price from the contract, transport contract. And the city we're passing in now is Jos, meaning the seller is at Jos, and the courier service started from Lagos. And then when it was at Abuja, the location was changed to Abuja. And now that it has been delivered to Jos, it should tell us if the function was executed successfully. And then we have this should check the courier location from the buyer contract. And as you can see, when the buyer checks the courier location, this was already changed to Jos. This should definitely be close to Jos. If not, give us an error. And then we have this check courier status from the buyer contracts. Since it has been delivered here, this should give us delivered when we check the status. And if it's not, give us an error. And then we have this one that is now sending the price of the item to the seller address, which is calling the receive item function now. And if you remember perfectly well, this receive item is calling the seller received item function that checks if it is the caller, if it's the buyer that is actually making that function call. And lastly, it's sending the contract balance to the seller address now. And then we have the last test that is actually checking the seller contract balance from the buyer contract. So we have this that is now checking the seller contract, and if this was successfully run, this should give us a 0 because it has sent our 100 ethos now to the seller. So that's about the unit test script. Now let's see how to deploy, and that is done in our deployment script, which is located at the deployment directory in the deploy.js Fine. So just like how our test script deploys our contract, our deploy script also deploys our contract. And with this deployment script, you can choose to deploy a contract to mainnet or to testnet. So we wrote the same kind of method, but this time around, our new deployer is now taking in the network, the private key, the compiler, and the network ID. Then we have this buyer key pair, which it is to give us, to help us add the buyer address to the contract. So just like how these functions were called in the unit test script, we have the same in this script. So that's that about the deployment script. So now let's execute commands to test and deploy our contract. If you have not forked the example repo, do so, and then head to the SmartShop directory, as I did. And what you would need to do first is to install the required packages using npm install. So the best thing you should do is to click on this SmartShop and open it in the integrated terminal. So once you have it installed this way, make sure you check your directory and you make sure it's ending with the SmartShop. Then you can run your npm install command to install the required packages. I have that installed already, so I don't need to run it. But for the sake of spelling, let's say npm install. This is what you need to run. And after that, it installs the required package. And then after this, what you need to do is to make sure your Docker alongside Docker Compose is running so that you can start your local node and your AE project compiler. So to start that, all you need to do is to run this command, AE project env. So when you run this, it helps you start your local node and also start your local compiler. You can either choose to start your just node with AE project node, and that will just take care of the node. But for this purpose, what we need to do is to run our node and our compiler. Now, when we do this, it's going to give us our 10 wallet keys, key pair, which we made use of in the test script. So out of that 10 wallet is where we're making use of the first one as our owner key pair and the second one as our buyer key pair. As you can see, we have this running already, where the minor key pair is this, which has this wallet balance, and the first, which is this key pair, and we have all this, and it keeps loading till it's 10. We have 8 already, and we should have the last one, 9. So as you might be wondering, why is this 9? That's because it's counting as an array where this is starting from 0 to 9. So we have our 10 keys now, and we can now run our AE project test command. To do that, all we need to do is to run the AE project test. And if you're trying to run that command and you get an error message that says cannot find the module AE project init, what you need to do is to install some packages. And you can do that using the npm install AE project utilities. Then you need to install prompts. That should be prompts. And lastly, you need to install AE project logger. Okay, when you run this command, it installs everything you need and it won't give you that error again. So now let's test our contract with the AE project test command. So what this will do is to first deploy our contract, which, as you can see, it's showing deploy contracts. After deploying the contract, then it will interact with the contract and then deploy the contract again. and then execute the contract functions. So it's running this deploy contract section at the moment. As you can see, our seller contract has been deployed to this address, and our transport contract has been deployed at this address. And lastly, our buyer contract has been deployed at this address. And you can see we have the green mark already, which means our contract deployed successfully. And then now it's performing this interact with contract section, where it has deployed the 3 contracts again, and it has run the first test, which was successfully executed. We have the green marks. The second one that checks the contract balance was successfully executed as well. Then the send item, and then the item status, and then the transport functions. And now it's trying to send the item price to the buyer, which it has done, and it has changed seller contract balance to 0. Great. So now we have this AE project test command that successfully ran. So let's try our deployment command as well, and that is AE project deploy. Okay, so what this will do is just to deploy this contract again. So we can see that this deployment script and the test script works perfectly well. So we have the seller contract has been deployed at this address, and the transport contract has been deployed at this address. Great, the deployment script successfully finished successfully. And for the test, we got this message that says there is no Sophia test to execute, meaning it finished 15 tests in 1 minute. That's really amazing. So now that we've seen the successful message, what we need to do now is to stop our local node and the compiler with AE project END flag stop. And the flag now is taking the 2 dash symbol. So we run this, and that should stop our node and compiler. So you see this message already saying stopping node and compiler. And the first thing, node was successfully stopped, and now compiler was successfully stopped. With this, you are good to go in developing your own awesome app on Eternity blockchain. I'm Manuel Joseph Jett, and see you in the next video. Bye.